You're not done. The second question. Use 4 segments. Simpson's 1/3 rule. Be careful with that statement. To approximate the distance covered by a rocket in that, from that to that, as given by that. I love you. Let's continue. So now, you see, we have to use 4 segments Simpson 1/3 rule. That's why I'm saying that it is like n segments. It's like n segments Simpson's 1/3 rule. So if you don't hear something like something segment, that means that it is talking of the single what? Single segment. So this is the multiple segment. That's why you have the 4. So now let's continue. So A, use 4 multiple segments. You see that? That's the multiple. So use 4 multiple segments, Simpson's 1/3 rule, to estimate what? S. So let's say that, let's see how we go about it. It's just easy, it's not difficult. Alright. So now you just have to write your formula, right? So the formula for this is not the same as the one that you know already. The multiple segment, I will say the multiple segment is the same as the composite one. The multiple segment is the same as the composite one, and the single segment is the other one that you know. So this one is the same as the composite one. Alright, so that is changing S over 3, then F S naught. I'll come back. Alright, so that's the formula we have on the board. So from the question, we know that we have to use how many? 4 multiple segments. That means that our n is equal to 4. How we can see the difference? And the a is equal to 8. And the b will be equal to 30. So we know the change in s will be equal to b minus a over what? N. So that is going to be 30 minus 8 over 4. And that is going to give us 5.5. Alright. Then, here we go. So, the first thing is that we are going to use the function now. All that we are going to do is the function. Alright. So we are going to start from the lower limit, which is what? 8, to the upper limit, which is what? 30. By what? Adding the what? The number of what? The delta x or the interval. So we add till we get to what? 30 before we can stop. Alright, so now let's start. So f of, alright, now let me give you something too. We know this is the general formula, right? But from the question, it's a function of what? X. In terms of what? T. That is what we are dealing with. That is time. So we have to change this to T. This to T. This to T. 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 That. Alright? Okay. Don't forget that. So this one we have to change it to, let's say, delta T. Okay. So let's go. So now, we know f of t naught, that is the initial to be what? F of what? 8. What this means is that this is the value that we are looking for. Alright. So what this means is that in the function of f of s of t, in the function of s of t, where you see t, put what there? 8. And the results you are going to get for that is 177.25 meter per second. So that's what you are going to get for that. Let's continue. Alright? I love mathematics. I hope you also love it. Okay, so let's see. Oh, okay. So that is that for that. So now, we are now moving to where we will add the delta, the change in the what? In the time. So, And now coming to f of t1, which that one too will be equal to f of, that is t naught plus the delta what? T. The delta t. So that one will be f of 8 plus 5.5. And when you substitute this, so that this one is the same as 13.5. So in the function f, in the function L, it should be x. All right. It should be x. Don't forget that. Okay. So in the function s of t, where you see, but when you maintain this to be f, no problem. Just know what you're doing. Where you see t, put what there, 13.5. And when you do that, you are going to get, so you get 320.25 meters per second. And you move to, I'm still repeating this, but you can maintain it, it's still the same thing. So that means that this one too will be T naught plus 2 of what? Delta. That's 2 times what? Delta T. And that one too will give you, that one too will be 13 point, sorry. Okay, so the results here, you add the 5.5 again, and that one will give you f of 19. And when you do the substitution of f of 19 into the function, oh, you can maintain it to be f. Into the function that we know, you are going to get 484.75 meters per second. Then you move to the next one. So we are moving till we get the 30. So we are now at 19. So we move S. Okay. So now 19 plus 5.5. How we going to see that? Alright. And this will give you S of 24.5. And when you do the substitution into the original function, you are going to get, alright, so you're going to get 675.05 meters per second. Then you move to the last one. And in this case, when you add, you are going to get S of 30. And when you do substitution of S of 30, that one too will give you 901.67. How you are passing through the process is because of the time. That's what I'm doing like that. It's just substitution you do. Alright, so after getting this, then you now come and approximate it. Alright, so that is that. We have the 30, so we can now end there. So we can now end there. So now, we're just coming to, alright. So now we are just coming to, so we now go and do the substitution. You know that the formula will be in the form. Oh, what is all this? Alright, so now we have our formula to be in the form, that's 22 over 4, 3. That would be f of 8 plus 4 f of 13.3. We can limit the f, we can make it f plus 4. So, okay. Okay, so now 2 f of 19 plus 4 f of 24.5 plus f of 30, and that is that. And this is going to give you 11 over 6 Alright, it's just substitution I'm doing. It's just the substitution I'm doing. Plus 2 multiplying 40, 84.75 plus 901.67. And when you compute this, you're going to get 61.64. Alright, so that's going to be the answer for that. Now, I'll be back for the B and the C. Alright, welcome back. So that's going to be the solution. I hope you also solve it. So the exact value of the above integral is, because from the formula you need what? The true value minus what? The approximate what? Value. So you first go for the approximate, the true value. That is you punching the whole thing on calculator and you get it. So this is the calculator work. Alright, and this is the approximate value is the results that we have, and that is that. When you subtract, you get it. Alright? Thank you. You can ignore the negative. And when you come to this side, the absolute relative error. So the absolute relative error is the true error over what? The true what value times what 100. And that one too together. See you for another video. Bye bye.